Hi everyone, welcome back to Deep Dive Daily. Okay, get ready because today we are diving into a theory that sounds like it's been ripped straight out of a sci-fi movie. But, and you gotta hear me out on this, it has some seriously fascinating science to back it up. We all think of life as being uniquely Earth's thing. But what if its true origins are way older and from a completely different world? Let's get into it.
No, I want you to really think about that for a second. What if the very first spark of life, the one that eventually led to us, to everything we see around us, wasn't from here at all? What if it was an immigrant, a traveler from our rusty red neighbor, Mars?
All right, so picture this. It's about 4.5 billion years ago. If you were placing bets on which planet would cook up life first, you probably wouldn't have picked Earth. Kinda surprising, right? Mars, since it's smaller, actually cooled down way faster. That means it had a solid crust and liquid water long before our own planet did. We're talking a potential 100 million year head start to get the whole life party started.
And this isn't just guesswork. We have some seriously compelling evidence that early Mars was a vibrant, watery world. Our rovers have shown us the fossilized remains of ancient river valleys, massive lakes, and maybe even a huge northern ocean. Get this. NASA's Perseverance rover found a rock in the Jezero crater, an old river delta, that had organic molecules in patterns that, here on Earth, often point directly to life. So the clues are there.
So if life did get a foothold on this ancient Martian water world, it was in for a really rough time. The early solar system was basically a chaotic shooting gallery. Mars got absolutely pummeled by a relentless 300 million year long storm of asteroids. It sounds apocalyptic, and it was. But here's the twist. That catastrophe might have been the very thing that allowed life to spread.
So here's the crucial part. These massive impacts acted like cosmic cannons. They were so powerful, they launched billions of tons of Martian rock clean out of the planet's atmosphere and hurled it into space. And where did some of that rock eventually end up? You guessed it, right here on Earth. We've even found them. There's a famous meteorite they found in Antarctica that we know came from Mars.
And that brings us right back to that mind-bending question. If rocks could make the journey from a potentially life-bearing Mars all the way to a young Earth, well, what if they weren't traveling alone? What if microscopic organisms hitched a ride? This right here is the core idea behind the theory of panspermia.
Of course, this would be the most extreme road trip in history. For this to work, any form of life would have to survive what we can call the gauntlet. First, the launch. You're getting blasted into space at insane speeds inside a rock that's been superheated to over 1,000 degrees. Second, the void. You have to survive for potentially millions of years in a frozen, irradiated vacuum. And finally, the re-entry, becoming a literal fireball as you plummet into a new atmosphere. It sounds completely impossible, right?
Well, maybe not. Because we have creatures right here on Earth called extremophiles that basically laugh in the face of these challenges. Spores of Bacillus subtilis have survived being flash-heated to insane temperatures. The incredible tardigrade, or water bear, can survive the vacuum of space. And then there's the undisputed king, Deinococcus radiodurans, which can literally have its DNA shattered by radiation and just rebuild it in a few hours. No big deal.
Okay, but what if life didn't even have to survive the journey intact? This is where it gets even more fascinating. There's a variation of the theory called necropanspermia. The idea here is that even the dead remains of microbes, carrying fragments of DNA and other essential building blocks, could have rained down into Earth's primordial soup, providing all the ready-made ingredients needed to jumpstart life here.
I mean, think about that. It suggests our own biology might be written with borrowed words from an ancient alien story. The very code that makes us us could have been pieced together from these microbial martyrs that didn't survive the trip but delivered the critical blueprints.
But this wasn't just a one-way street from Mars to Earth. Not at all. Our solar system was, and still is, a bustling trade network. Scientists estimate tens of millions of Earth rocks have likely made it to Mars. Venus, it might have received 100 times more. Fragments have probably even reached Jupiter's moons and Saturn's moon Titan. It's like a vast interplanetary asteroid highway.
And if you thought that was a big idea, get ready, because we're about to zoom out even further. What if this exchange of life isn't just limited to our solar system? What if life is connected not just between planets, but between the stars themselves?
Now that seems like a huge stretch, I know. The average distance to our nearest stellar neighbors is about 40 trillion kilometers. That is a journey that would take millions of years longer than a trip to Mars. making survival seem even less likely, but maybe not impossible.
So how could it possibly happen? Well, a few factors make it plausible. First, most stars, our sun included, are born in these dense clusters where neighboring stars are way closer. We're talking light weeks apart, not light years. Second, comets with their super thick, icy shells would be perfect natural radiation shields. And studies show that just 3 feet of rock can protect microbes from cosmic rays for tens of millions of years.
So get this. During that early period when our sun was still in its birth cluster, simulations suggest that as many as 200 billion rocks from a young, life-bearing Earth could have been ejected and actually reached alien star systems. We might have been the ones doing the seeding all along.
Okay, so now we're going to get even more speculative. We've been talking about life as a passenger, but what if, for some forms of life, a rock or a comet isn't a vehicle, it's a cage? What if life could travel on its own?
So there are trillions of these rogue planets just wandering through the galaxy, planets that got ejected from their home systems. While their surfaces are frozen solid, some could have molten cores that heat vast subsurface oceans. These hidden biospheres could basically act as cosmic lifeboats, sailing through the void for billions of years, using the entire planet as a starship.
And here is an even wilder thought. What if life could actually construct its own habitat? Just imagine communities of cells weaving a living shell to block radiation and hold in heat, water, and nutrients. They'd be these self-sustaining bubbles of life, just drifting between the stars like cosmic plankton.
And that brings us to the ultimate version of this theory, directed panspermia. This is the idea that an advanced intelligence could be intentionally seeding the galaxy with life, treating it like a vast cosmic garden, maybe to preserve their own biology, or maybe just to see what grows.
Which leaves us with this final staggering question. Is our entire existence, our whole tree of life, just one tiny branch of a story that is vastly older, larger, and more interconnected than we ever imagined? What an incredible journey. So what do you think? Could we all actually be Martians deep down? Hit that like button if you enjoyed this, share it around, and subscribe for more. And definitely drop a comment below with your views. Thanks for watching.